Algebra students! Oh, I'm so glad I get to be with you on this seminal day of your algebra education. This is like maybe the most main algebra lesson the whole year. 9-5A, solving quadratic equations. Oh man, do you remember what those are? You probably forgot. Ax squared plus bx plus c equals 0. Boom! Using the one, the only, the most famous formula in all of algebra, the quadratic formula. And today, unlike just, a lot of algebra classes, you just go in and, here it is, just use it. No, man. We're going to figure this out. We're going to derive the quadratic formula. I can hear the moans. I can hear the groans, which is my whole goal, you know what I'm saying? Okay, how do I derive the quadratic formula? Oh, I'm so excited. You guys are gonna love this. And by love it, I mean you're gonna endure it, and then you're gonna be like, it was okay. It wasn't as hard as I thought. Or you'll come away going, what? I know some of you out there right now are like, that's me. He described me perfectly. Okay. How do I derive the quadratic formula? First, let's go over what in the monkey sauce we talking about here. There's no concept and example. I don't even know why I have those two sides, but I'm excited for you all. This is, well, for you all of you, every single one of you. Hi. This is the first day that we're doing some seriously difficult algebra to solve for a seriously useful equation. Here's what we're going to accomplish. This is the form of a quadratic equation. A quadratic equation looks like a quadratic function, but instead of having the output y, it's just a 0, right? So in other words, if y is equal to 0, what we're solving for is x. That means we're really finding the x-intercepts, right? Or the zeros of the function, as we say. The x-intercepts are located where y is equal to 0, right? X comma 0. So it's like a quadratic function, except for y is 0. That's what a quadratic equation is. Okay, now in the past, way back a long time ago, when the dinosaurs ruled the world, we would solve this for x by factoring the left side of the equation to get something like this. Quantity px plus q times quantity px plus q is equal to 0. Actually, I don't know why I used p and q both times. That was a mistake, but whatever. The point is we wanted to use the zero product property by having factors equal 0, right? Factors equal 0, and then we set each factor equal to 0 and we solve for x. But this time, we're not factoring on the left side. What, you say? Instead, we're going to solve ax squared plus bx plus c equals 0 for x. That's right. We're going to solve for x. We're going to make x equal something with an a and a b and a c and blah, 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 blah. This is super shreddy nar. That is how you spell nar, starts with a G. Because we aren't going to substitute any numbers. We're just keeping a, b, c, and x. That means we want x all by itself on one side of the equation. But how? Don't worry, we're going to do this. Everybody, take a deep breath, and then don't actually take a deep breath, because I know that you don't. You're like, I'm going to do the opposite of whatever you say because, like, that's fun. I understand. I also do the opposite of what I say. So don't eat chips and salsa. Okay, first, let's factor out the a. To do this, put an a in the denominator of the bx and c terms. I know right now you're going, wait, what? We have ax squared plus bx plus c equals 0. We're going to factor out an a. We want x by itself. First, we're going to factor out the a. If I factor out the a, I get a times what is ax squared? Well, x squared. A times what is bx? Wait, a times what is bx? I know. A times bx over a. If I multiply by a, won't the a's cross cancel? You'll have a over 1 times bx over a. The a's will cross cancel, just leaving me bx. Using the same exact idea, a times what is c? C over a. Okay? Now you might think, well, we just made that more complicated. I know that's what it seems like, but we didn't. Okay, now the next part, it says, the next idea here, I don't know why this thing's so slow. Okay, divide both sides of the equation using the division property of equality by a. Don't forget that 0 divided by any number is 0. Well, except for if you divide by 0, but let's pretend a is not 0. Okay, so I'm going to divide both sides by a, and I'll actually show this, even though it's going to be a little bit nuts trying to show it. But you know what? I'm going to do it for you guys because I care, okay? I care a lot. Okay, we have bx over a. Oh, I almost did that, huh? I almost achieved the impossible, the unthinkable. Okay, plus c over a equals 0. Okay. So on this step, I'm going to do it in a different color. I'm going to use the division property of equality and divide both sides by a. These a's cross cancel, right? And this is equal to 0. So going back to blue, I'm going to be left with a or x squared plus bx over a plus c over a equals 0 divided by a is 0, right? So far, so good? I think so. And now we're going to complete the square. We're going to complete the square. Do you remember the b divided by 2 quantity squared? I know. You're probably looking at this and you're going, Mr. Plunkett, I don't think it's possible, bro. I just don't think it's possible, man. It is possible. We can actually do this. So what we're going to do is we're going to first write what we had, so you're not too freaked out. Oof, ah, oof, ah. Okay. Okay. Remember, we have x squared plus bx, and in this case, our bx is just b divided by a, but that's no big deal. I'm going to put the plus c over a way over here equals 0. And remember this: when we complete the square, we want to add something. We want to subtract something. Okay? Well, what are we adding and what are we subtracting? Well, usually we do b over 2 squared. Well, but now we don't have b. We have b over a. But don't forget that bx over a is the same as b over a x, right? So that means that our b, in the when we complete the square, our bx term is just b over a. It's a fraction, but that's cool. We can deal with that. So now we're going to take this fraction, which is our b. We're going to divide it by 2. If you take a fraction like b over a and you divide it by 2, and I don't know if I can actually show this, but I'll try my best. If I do b over a divided by 2, it's the same as multiplying by the reciprocal, right? So keep, change, flip, that whole thing. So that's an A, by the way. It just looks really bad. It looks like a Q. I know. You always have fun figuring out what other things it looks like. This is B over 2A, right? So taking this B over A and dividing by 2 is B over 2A. But then we have to square that, right? So we have B over 2A. Can he incorporate the mistake? Yes, he can. And we're going to square that, right? Okay, so now we have this fraction and it's being squared. Hopefully you remember that this is the quotient property, or I should say quotient of powers property. So that squared gets applied to both the numerator, b squared, over, and the denominator. 2 squared is 4, and a squared. There we go. We took b, we divided it by 2, and we squared it. So b squared over 4a squared. So now I'm going to add b squared over 4a squared. And I'm going to subtract b squared over 4a squared. All right. Now, check it out. You all remember this, right? What's the point of that? The point of that is that this trinomial is now a perfect square trinomial. It's a beautiful perfect square trinomial. So how do we write that perfect square trinomial? We write it like this. Actually, let me use blue since that's like our main color here. That's x plus, and I don't know if you guys remember this, but the second thing that gets squared is the b divided by 2 term. Now the b divided by 2 term was the b over 2a. Remember, we took b and we divided it by 2, and we got b over 2a. So that's b over 2a. And then we still have the minus b squared over 4a squared, whoa, plus c over a equals 0. Okay, I'm going to stop this video so that I can split it into 2 segments that are under 15 minutes so that YouTube's happy. And I'm going to film the second segment right now, so there will be 2 parts on Google Classroom.